Oh, yeah. Right. Okay, so what I want to do today is I want to talk about the status of my build. Things have happened in the past 5 or 6 weeks. And I want to talk about Rover Liberation. Okay, so when we talk about the current design status, there's a few problems that I've recently solved and some new development in the works. And when I talk about Rover Liberation, I'm going to talk a little bit about music and rhythm. And I'm going to talk about the Feral Garden Rover, which is perhaps a goal that I'm aiming for. Okay, so last time I spoke about different things. Let's see how they moved along. As a Mars Garden, I contacted the local Mars Simulation Center, and they told me that they just got a group from the European Space Agency who are going to spend a month in pretend Mars conditions. So they're too busy to talk to me about anything, but I'll call them up again in a month. The whole idea of porting and collaboration between the rovers, if you were listening last week, seems to be moving forward. And the issue of, do I need to rewrite, refactor the software? The answer is it's happening slowly but surely in view of the problems I meet. Okay, so status update. I'm going to talk about the bus problem I had, got even better. I'm going to talk about command enrichment, and I'm going to talk about other things in process. Okay, so if you remember when I last presented, I have a problem that when I try to log the status of the rover, each logging cycle, which collects all the information about the rover, takes between 1 and 4 seconds. And the question is why? And the answer is that a single cycle of reading a single servo takes on the average 42 milliseconds. So if I have 18 of them, that's nearly 800 milliseconds just to read them. And the question is why? And if you remember the way the software is written, you send a command to a servo saying, tell me your position. You wait for an answer, and if you don't get an answer, you send the command again. And it doesn't happen, you send the command again. And it takes 10 times or 20 times or 40 times or whatever number it takes. Now, it's very strange because the internet says that when these servos are very fast, so when you give them a command, they answer immediately, like within less than 1 millisecond. Got some new hardware. And this hardware is called the PL2303. It's a very simple piece of hardware. What it does, it converts TTL, you know, transistor level signals, 3 volts, 5 volts, to USB. Most serial buses are TTL. The bus that the servos are connected on is also TTL. And I'm not sure if you remember the architecture of the bus of the smart servers, but basically we have the computer on one side, and we have 6 chains, and each chain has in it 3 smart servos. So it's some sort of tree structure, but every command on the bus is propagated over the entire bus. And what that means is that if you sent a command, you know if you sent it to the bus or if you're receiving it. But if you didn't send the command, you don't know who's sending the command and who's receiving it. So what I'm doing is I'm reading the bus using this device. So on the one hand, the Raspberry Pi is sending commands over the serial port onto the bus. And on the other hand, I basically added a new serial port, which is also listening simultaneously on the bus. And this is what the connection looks like. You see, one end is connected to this servo over here. Servo here, servo here. This little white thing is a port, so it's connected to the port. I used some wires I found hanging on a tree in the garden, and they're connected into the PL 2303. It's a plug and play on Linux. And I don't know if you're familiar with Minicom. It's software for setting up and talking on serial ports. And it didn't work. It turns out that you need to swap the ground and RX legs. They're not marked on the servo, and then it works. I wrote a Python script, and basically what I'm doing is, on one window, I'm continuously reading the serial port, and it shows me what's happening on the bus. And in the other window, I am sending commands, walk forward, walk backwards, log, and so on. Now, these windows are windows on the robot itself. That worked. So what it means is that I get a stream showing me everything happening on the bus, both commands that I'm sending and responses sent back by the servos. They actually have a similar structure, but you can distinguish between them. So I wrote a better Python script, which decodes everything happening on the bus. It shows me what command, who sent it, whether it's a command coming from the computer or whether it's a response coming from the smart servo. And I added the functionality of calculating the checksum. And finally, I let it run for a few minutes and looked at the data, to see what's happening. So I'm reminding you, the symptom is that from time to time, you send me position and you don't get an answer. That's exactly what we see also in the output of the bus. You see it saying, send position, send position, send position, and nobody's answering. When I looked more closely, I saw that the commands appear to be okay, but the checksum is wrong. Okay, so if you think about what a packet looks like on this bus, you have a header, which is fixed, just so you'll know it's a beginning. Then you have a body. Then you have the length, and then you have the checksum. In fact, perhaps I will show you in the book what it looks like. I'm sorry I didn't put it in the presentation. Just a second. Okay, so this is what a packet looks like. Fixed header, ID number, which is which smart servo is supposed to be getting it, the length, the command itself, which is something like servo move, servo ID, servo angle, whatever the command is. Then you have parameters, and then you have a checksum. When the servos send a response, it looks exactly the same. Just a second. Okay. Except, I'd like you to notice when you send a command, it has a length. And when you read a command, it also has a length. So servo move time read is command number 2 and a length of 7. But when you send it from your computer, the same command only has a length of 3. And the difference is that when the servo is answering, it puts in the data that you wanted to read. So if you encode this table into software, it's very easy to know who's talking. Okay. No, just a second side. Okay, so now the question is, why is the checksum getting damaged? So I checked the software, and the packet itself is sent okay, and the software is sending the correct checksum. But if you remember how this bus is set up, there's only a single data wire, and there's no flow control. So the computer has to decide whether it's in talking mode or whether it's in listening mode. So the way it works, you send a talk command, and you say, okay, now I'm listening, and then you listen for the response. But the minute you move into listen mode, it cuts off any transmission you were doing, which actually means that you're cutting off the transmission at the checksum byte. So the checksum arrives corrupted. So basically, I increased the delay from 0.0034 seconds to 0.0004 seconds, and the problem went away. Okay, so all of this shipping pieces over from China, connecting wires, was only in order to make a small change in the software. But now, of course, the time is 150 milliseconds instead of at least 800 milliseconds, which is, much better. So I checked it out and everything's working fine. And now the only question is, should I continue working in this mode? And on the one hand, it's a very good logging tool because I simply log everything happening on the bus. The USB provides buffering. Because it's a serial port connected to the USB, the data doesn't have to be read the instant it arrives. And I can also avoid having any read-write switching on the buses. Instead, I can talk from one serial port and listen to the response on the other serial port. So we have to see what happens. It's a tricky piece of software to write because I'm writing using one serial port. I'm waiting for a response on a different one. So it becomes not synchronous anymore. But, we'll see. Okay, so from my perspective.
One comment about, do you know what a logic analyzer is, Maier?
Yeah, I do. This is self-analysis.
Okay, yeah.
I know what a logic analyzer is, but I don't have one.
Yeah. So it helps in debugging these protocol problems generally a lot.
Oh, so absolutely.
Yeah.
Listen, when I was a child, so to speak, the guy in the lab I was working at showed me how you use a VT100 as a logic analyzer for serial ports, but I don't have any. Okay, but the minute you have this little piece of hardware that converts TTL to USB, so the robot itself can act as a logic analyzer. which is of course very convenient because when it moves, I don't disconnect any wires.
There is a version of BeagleBone hat called Logic. I don't know if it's still maintained. So if you have a BeagleBone, you can buy that hat and then convert your BeagleBone into a logic analyzer. So it's a completely open source project. So it's a relatively cheaper logic analyzer.
But this piece of hardware costs 70 cents.
Okay.
You can't go cheaper than that.
Yeah.
No, I also opened the dispute because I felt I was overcharged and I asked for $1 back. But it turns out I wasn't, so I gave back the dollar. But actually, Anuraj, I think it's an interesting time to point out all of those hardwares you've been putting on the channel.
Okay.
Okay.
So
now I just want to make a comment. You know, all of those hardwares are very cheap pieces of electronics, about the size of this PL2303, but they can provide not only reading the signals, but also processing them, and they can be connected to multiple sensors simultaneously. So when we talk about the correct architecture for a robot, rather than how to make the one that I have work better, I think that's the way to go. So Anuraj, you want to tell us a little bit about them?
So yeah, on the Discord, our Yakrover channel, there is a thread called Embedded Ecosystems, where I post whatever I find through the various channels. I encounter these electronics. So it's mostly a lot of embedded boards and sometimes something related to embedded. So it might be just better to occasionally check it out if you are looking for something specific in the embedded domain.
Can I make a suggestion about this? I think this will be useful to sort of capture in a more systematic way. So can we use the link, what's our dollar command for link, the reading ad, right? Dollar reading ad. If we can use that, that'll capture it in a way that can be more easily scraped later. Like at some point, we may want to build like a little database of components that we like.
Yeah, but the current problem is that our commands don't work in threads.
Oh, crap. Okay, never mind.
And there was some problem with the Discord library also we are using. So it needs some improvement.
Let's not talk about that. That's painful. I don't want to talk about it. But I do want to comment that I think what we really want to do is build the module, which is one of these RP2040s connected to 3 or 4 sensors. And I don't know how you've been following, but one of the options is a module which has Wi-Fi and can connect to the sensors and can be powered by, you know, a small battery. And the reason that's good is wires. I want to remind you, you know, the picture from, okay, this is one wire. Now it's true that this wire, because it's connected to a bus, is able to give you 18 different sensors, but that means that we have wires connecting all these sensors together. Now imagine we had an angle measurement sensor over here, and we had a pressure sensor over here. How do we get the data back? And the answer is one of these modules, you can put the module over here, and it has a short wire here and a longer wire here, and it connects to the, let's call it home computer, using Wi-Fi. So that is a very modular and low wire method. And of course, there's no wires for cats to get attached to either, for those of us who have cats next to the robots. And the other things that Anuraj showed was a little module which includes a camera in it. So a pity it's so expensive, you know, it's $50. But imagine that this rover had a camera on each leg. Okay, and the camera would be processed locally in order to detect things like, where's the leg going? Does it have an obstacle ahead of it? You can just imagine what you can do. And all of these things are very modular because you just attach it on and it talks to your central computer and gives it processed information. So it doesn't add to the load. It's not real time in the sense that you don't have to control it using real-time methods. And the reason why I'm saying all of this is because actually building one of these modules would be very useful for hobbyists, much more than having a list of cool modules, because cool modules gives you ideas. A module which is already set up that you can connect to a rover, that's much more than that.
Yeah, so you can get the Espressive ESP32 in $20 with the camera integrated. So that is a little cheaper, and yeah, but it doesn't have the ARM Cortex CPU.
Yeah, well, but you need the Wi-Fi. I think the Wi-Fi is critical in order to reduce the complexity of the system.
Yeah, so it has a Wi-Fi with the camera integrated and a mic in $20.
And what kind of processing does it have?
It's powerful than the ARM Cortex M0 Plus that's on our Raspberry Pi Pico. But it's a different architecture, yeah.
Okay, we only have to choose one.
Yeah.
Okay, so next issue is command enrichment. As those of you who did the remote control of my rover might be familiar with a particular type of command, which is an action group. You tell the rover move forward 5 steps, and the rover moves forward 5 steps. And the way it does that is by having a set of commands arranged in a sequence. What is a set of commands? Which servo, what angle, how long to move to that angle. That's a command. And an action group tells you at each point in time how many how long you have and which servo to move for that amount of time. Perhaps an example would help. Just 1 second. I apologize that not everything that should be in the presentation is actually in the presentation. You see the Excel file. Okay, so this is what an action group looks like. What you have in the action group is time, servo 1, servo 2, servo 3. And now, line 1. Over the next 1,000 milliseconds, move servo 1 to location 499. Move servo 2 to location 310. Move servo 3 to location 120. That's one line. Then you have the next line. Over the next 300 milliseconds, move servo 1 to 499. And you can see it's very similar, except that this servo is a little bit different. Okay, so this is what an action command action group looks like now, and there's 19 lines. By the way, this is the rover walks and it lifts up its legs and does like that. Okay, besides being unreadable, the real problem with this structure, I think, is that it's very utilitarian. In other words, you tell it exactly what to do, and it does exactly what you tell it to do, except when it doesn't, because the servos do not always do what they're told. They try to do what they're told, but if they feel resistance, they stop moving. They don't insist on getting to the angles they were told to get if there's too much resistance, or if the time runs out, or if you give it a new command which bypasses the previous command. So right now, the rover is built to have, you can take a single servo and tell it 100 milliseconds to get the position 499. Or you can have an action group, which tells it for 1,000 milliseconds do this, 300 milliseconds do that. Or you can also have inverse kinematics, where you tell it moves the tip somewhere, and it calculates what moves it needs to do, and then it does those moves. Okay, but in all of the cases, it's really a top-down architecture where you tell the robot exactly where to be. Now, why is this good? Because it makes the legs act more like wheels. Those of you who have wheeled robots, you know, it's very simple. You tell the wheel to turn on, or you tell the wheel to rotate at 20 degrees, and that's that. You don't have to think too much.
Is the inverse kinematics fast enough on the aspect?
Software is fast.
Okay.
You have to think about the rover. It takes a step. It takes it about a second, half a second to do a step. It's not nothing special. So what I decided to do, for reasons which you'll understand in a minute, is to improve what an action group can actually look like. And let me just show you what the improved one looks like. Okay, so this is exactly what you saw before. There's a time, and each server is told what to do. Except, if you notice, some of the servos are given a number. Some of the servos are told no operation. And some of the servos are given a relative number. Now, most of the servos we don't want to tell anything to. So if you look at this, servo number 2 is the elbow joint. Okay, the robot is like that, can move like this and like that. So if you look at the first command, it means it's the elbow joint of leg number 1, this one, goes to 200 to 400 to 200 to 400. And here, servo number 5, which is the elbow joint of leg number 2, goes minus 100 plus 100, minus 100 plus 100. Okay, so I have relative motion. I don't need to know where it actually is. I just need it to tap up and down. And we'll see a tapping video in a second. And, well, there's the same. So first thing I did was I added the option of a speed ratio, where, if you remember, the action command is 1,000 milliseconds or 200 milliseconds. I can tell it multiply everything by 1.5 or divide everything by 1.5, so the rover will move faster or slower. I added the option of relative movement, which means that wherever you are, you do whatever movement it is. I added the option of locking or unlocking a servo. It means that if one of the legs gets caught, I can unlock it, so now it will drag behind the rover. I added the option of no operation, which means that you don't tell the servo anything. It stays where it was before. I gave it the option of applying an action group to only some of the legs. So it's exactly the same action group. You saw one now, which has 2 tapping commands in it, tapping for leg number 1 and tapping for leg number 2. But I can tell it, tap only one leg or tap only the other leg. Why did I do all of this? Because I wanted to have the flexibility of giving the rover more interesting movement commands. And in particular, I wanted to make it easier for software which generates commands to be able to generate them on an intermediate level, not the level of a single motor and not the level of the entire rover using action groups, but I wanted to be able to take a complicated action group and say apply only part of it, or take 2 action groups and apply them simultaneously. And we'll see a video in a second. Okay, so now let's segue. I showed you Excel files, actually CSV files, but the action groups are actually saved as SQLite files. And I was wondering, why would they use SQLite files if action groups are always read, and this is always read from the beginning to the end? You do line 1, line 2, line 3, and line 4. And then I realized that the reason is because development software, which they provide for editing the action groups, gives you random access, which allows you to go to any part of the file and change a number. And they, just to make it easier, they decided, I'm guessing, to use the SQLite format also when you carry out an action group. So you have something funny whenever you have an action group, it reopens an SQLite file. If you don't know, SQLite is a database format, and you read them line by line. I implemented using CSV because it's much easier to edit it using an Excel file, or even using a text editor. And it's also easier to generate them with a computer.
So you modified the library provided by the vendor?
Well, I've done a lot of modifying already, but yes, I want to explain. Right now, the way the software is structured, you write a program in Python, and you include a library, which does, there's a few levels, but basically include a library which carries out action groups, and that library imports a library which does the actual sending of commands on the bus. Now, Python, it's very easy to overload one of these libraries or to edit it. So, for example, if you remember from last time, I said I added a locking mechanism. The way I added the locking mechanism, meaning that when you send a command on the bus is locked until you release it, is I took the library of writing to the bus and I added what's called a decorator in Python, which means you do it before and after running a function. And the decorator says, ask for a lock, give back the lock. So I basically added a few lines of code at the beginning of the file to do that. Same thing with the action groups. I took the existing action group program and I simply added to it. And because it's in Python and not compiled, it's very easy to just add what to do if you give the computer an action group and the action group doesn't exist. What used to happen is if you gave an action group and it didn't exist, it would just tell you it doesn't exist. But now, if you give it an action group that doesn't exist, it checks to see if it does exist as a CSV file, and then it carries it out. So it's very modular in Python to take the existing libraries, add functionality in different places, and all of the old functionality continues working as before. Now, I realize all of this is going to change. I talked about refactoring, And what I'm thinking of doing is I'm going to change the entire method of talking on the bus into a Linux system service. So instead of using a Python library to talk directly to the bus, there's a program running all the time, and you tell it, send the following command to the bots. Now, it's not so difficult to implement, and I don't need to change any of these libraries but one. The library that talks to the bus needs to be changed. So instead of talking to the bus, it will talk to this system daemon. But I don't need to do it yet, so I'm not doing it yet. And closely related, if you remember, I work in a very script-based method, meaning everything I do is I run a Python script, and the Python script itself, in order to do what it does, runs other Python scripts. Obviously, that has some overhead. Right now, it's not a problem. But as it becomes a problem, I'm going to start collapsing it and turning it into libraries rather than scripts calling scripts. But during development, no problem. And that's, one of the advantages of using a Raspberry Pi and not a Arduino or some other smaller computer. So I also created a sequence command. Action groups are not sequence commands because the only thing you can do is exactly the same action group multiple times. An action group is move this, move that. And I added some more functionalities there. One of them is, of course, run an action group. One of them is pause, wait for 5 seconds. Another one is wait, no wait. I want to explain what that means. If you tell the computer to run an action group that, let's say, lifts up this leg, the computer spawns a new process to send these commands. And then it basically returns immediately. And if I now give a new command, pick up your right leg, that would happen immediately. So the rover could be doing this. So it's an easy way to compose different commands. If I tell it wait, it will wait for this one to finish before it starts doing this one. If I tell it no wait, it will simply do them at the same time with a delay of a few milliseconds between them. And the lock mechanism that I added will prevent the bus from clashing. And there's nothing to prevent the commands themselves from clashing. And I also added a push pop command. I can tell the rover, push on the stack the state of leg number 5. And then I tell it to do something with leg number 5. And then I tell it pop the state. So that enables me for the rover to walk and then suddenly do something and then continuing the way it was before. That's valuable, especially if you want to do dance moves, which Anuraj wants to do, I know. Two other things that I'm working on. Oh, I said in right here, modulate. Well, I already did it actually. Smoothing, right now, the commands are on off. Move this servo for within 1,000 milliseconds to this position. And what I want to do is I wanted to break down that command to 3 parts: an acceleration phase, a constant speed phase, and a deceleration phase, in order to make the movements less jerky. Okay, so that's not so important yet, so I didn't do it yet. But the other issue is timing. If you remember, I add the option of speed ratio. what I have now is a timing file, which tells me what speed ratio to use at each 100 millisecond movement. So it can be slow, 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 fast, 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 faster, faster, slow, slow, slow. And that is applied as a modulation on the sequence command. So you have the rover walking slowly and then faster, and then even faster, and then slowly again. And one of the reasons for doing that was, again, to put in the ability to do rhythm and music. Okay, so the hardware is ready, but music is not. And I'd love to get input from you. We'll talk about that in a few minutes. So 3 things that I'm working on. The first one is, how do you share data between different processes? The natural thing to do is to be using VOS. In VOS, you can publish data and you can read the data. But I haven't gotten to the point where I'm willing to take on the mental overhead of using VOS. So right now I'm using SQLite files to store data like the current position of the legs or the angle of the rover or information like that. And whoever generates the data writes it in the file, and whoever wants to read the data reads it from the file. There's overhead, but again, it's all happening in the memory, so it's not so bad. The second thing I'm working on is closing the loop. If you remember, I said the rover tries to move, it doesn't always succeed. Have all of you seen the movie where the rover is stuck on a step? Okay, so just 1 second. Okay, so the rover's walking, and you can see from time to time his legs get caught. Okay, still moving, it's fine. But now he's stuck. Okay, he's not managing to move forward. And you can see that some of the legs are managing to move.
By the asparagus.
Okay, here's asparagus, wild asparagus. So it could be trapped by the asparagus, and it could be because of the angle of the rocks. The question is, what is the rover supposed to do? And in that, we have to ask, at what cognitive level of the rover is it going to do it? So one of the answers can be, if this leg is not managing to move the way it's supposed to, the walking movement, maybe we need to pick it up and put it down. Or if this leg is stuck in the asparagus, maybe we need to somehow move away from the asparagus. So that's closing the loop. So right now, the software can tell what command it gave the motors and what commands the motors actually carried out. And the question is, what do we do? And one of the things I'm working on is some very low-level command, perhaps even in the sequence file, which says, I call it insist, okay? I gave you a command and I insist you carry it out. So if you fail to carry it out, you have to do something. And one of the things might be, let's call it evasive actions. One of the things would be you lift up your leg up in the air and then you put it down again. Another thing could be we take all of the legs and we try to push the rover away from wherever it appears to be stuck. And like I said, these would be at a very low level. The programmer would not be aware of them. He would just say, take evasive action. In other words, I insist you do something, and if you fail, you take whatever action you see fit. And one of the things I'm working on with Eric is trying to allow the Volvo itself to figure out what is the correct type of evasive action to do. But when I say have the Volvo figure out, I don't mean apply intelligence now. What I mean is the Volvo should have learned by now what type of evasive action to take in which situation, and just applies it automatically without using some deep logical method. Okay, but when it works, you'll see it. Okay, so till now was an update on what I've done with the Volvo. And I think what was most interesting to me in retrospect was realizing how the software that came with the Volvo was constraining my imagination on how I can give the Volvo instructions. That's what I feel was most interesting, because basically you could do whatever you wanted to, but because they made it easy to either move a single motor or apply a predefined action group, which takes a few seconds to carry out, that was a natural thing to do. And even when we talked about making more complex commands, we basically said, let's add it on top of these action groups. And the action groups, like I showed you, were very limited. You don't have relative movements. You can't tell him to lock a joint or to unlock a joint. And it's not a limitation of the Volvo, it's a limitation of how they built the software and how I looked at it. Okay, so that was status update, and now Rover Liberation. Okay, like information, Rovers want to be free. Now, I don't know how many of you are familiar with the charge of the Light Brigade, but usually we treat the Rovers according to this quote. We give them instructions. There's not to make replies. There's not to reason why. There's but to do, and on Mars, they'll die, we know. And the question is that what I want my Rover to do? Do I really want it to be that I give it a command, it really tries to carry out the command, and that's that? Okay, the answer is obviously no, I don't want to do that. I don't know about the rest of you, but I don't want to do that. That's just plain old robotics, building a machine that does what it's told to do. So just to remind you, the current logics that you can have are moving a motor to a position, moving an end effector, move until feedback, move the body. And another thing you can do is you can tell it to patrol, I'm sorry about the spelling mistake, and give it an instruction. If you find X, do Y. Now, these are logics that people use for Rovers in general, okay? Brings a package to the door, okay? That's move body from point A to point B. Patrols, that's more common perhaps in military robots, but again, go around, and if you see something, do something, okay? It's all very top down with a lot of control. And the question is, how do we set the Rover free? So I don't know the answer to that question yet, but I do have some baby steps. And the first step is to allow the Rover to have some personality. Like you have a character in a book who has a limp, who has a particular way of speaking, who gets annoyed when people call him a chicken, you know? These are all personality quirks. So the first quest I had was, let's allow the Rover to have some type of built-in personality. And a lot of what I did with command structure was in order to allow that personality to show itself in the way it walks. So just imagine I can very easily set it up now that when you're walking, you have a non-uniform gait, that you move your left side more slowly than the right side. It's very easy to set up. I don't have to reprogram anything. A more advanced level is to somehow expose the inner activity of the rover. Again, I'm not sure what that means, but I can definitely have the rover walk differently at a different speed based on its inner activity. The next step is to give the rover a sense of rhythm. Okay, so that really has two parts. Part number one is that the rover should be able to move using a rhythm, and we'll see that in a minute. But the flip side is that it should somehow feel rhythms. Think of my rover walking in the garden. It's walking on stone, and it's walking fine. Then it's walking on grass, and it's slipping a bit, and it's making a certain song, but it's really moving more slowly. Then it tries to climb over some rocks, and again, something changes. There's a rhythm involved. I want the rover to be able to detect this pattern, but not as some logical pattern of I've moved from the garden to the grass to the stony area, but rather simply as a rhythm. And of course, we close the loop where it expresses itself according to the sense of rhythm that it detected in the world. So the rover's walking, it's generating a rhythm when it walks, and now it changes the way it's walking, but in a rhythmic way in order to match what it sensed. You know, so the crazy idea would be that when the rover walks to a pile of leaves, you know, it's autumn now, so you have piles of leaves everywhere. When it walks into a pile of leaves and it starts making noise, so it starts making more noise because it likes the sounds that it's making. So that is not a liberated rover, but it's definitely a rover which has some type of its own personality. Which of course leads us to the question, what does a rover want to do? And I have no idea what the rover wants to do, but if we think of this idea of a feral garden rover, it's sitting in my garden and it acts the same way the cats do, which is lie around all day and from time to time chase a chicken or whatever. That could be very interesting. In other words, when my rover gets to Mars, it's going to expend a little bit of its abilities, resources, in order to do roving as a service for people who pay it. And most of its time, it's going to do something else, which I have no idea what. So let's a little bit more detail on some of these ideas. Built-in personality. Okay. So I think what's most important is the variation is on the low level. Okay, it's not part of the planning. You plan what you plan, but if I take two rovers, each one with a different personality and give them exactly the same plan, they will carry it out exactly the same way, except that on a low level, they'll do it differently. One of them will have more sliding, one will have smoother movements, one will walk more in a straight line. So a question that I asked is, what does a fun gait look like? Okay, a non-fun gait, I'll show you what it looks like. That's a non-fun gait. So what does a fun gait look like? I have no idea, and I'll be happy for any ideas. But the goal is that the rover should be able to have a fun gait. And I found a paper, an interesting paper, which compares pacing in zoo animals with what they call goal-oriented locomotion. And it turns out that there's a difference between them. The step size is different, and the variation is also different. Okay, so pacing, which is exactly the opposite of being fun, is basically low coefficient of variation and smaller steps. Okay, while when the polar bear, this is a polar bear, has goal-oriented, like it wants to walk to the other polar bear, it has a higher step variation and larger steps. So that is boring and utilitarian. Now the question is, what does a fun gait look like? Do you have skipping? Do you have tapping? I don't know, but stay tuned because I will know, or you will tell me. Interactivity. Okay, so I want to expose the interactivity of the robot. That's one of the way of giving it a personality, is you can see what's going on. So gait we talked about. There can be extraneous activities like tapping or like waving your legs in the air. And of course, we can add stuff like lights, sounds, or music, or general talking. Okay, so basically when the Rover is walking, you know that it's feeling something. And what it's feeling is tied to what's going on inside. I'm really overloaded. I'm confused about how to get out of here. I have what to do. I don't have what to do. I'm low on battery. But the goal is not for the Rover to say I'm low on battery, but to act in a way that when you look at it, you say, oh, maybe it's low on battery. Sense of vision. So just forgive me for a second. One of the advantages of having legs is that it appears to me to be much easier to add, to expose an inactivity. I have many more moving parts which I can do something with than in a wheeled robot. In a wheeled robot, I can move the wheels forward or back or spin them. And I have 1/4 of the number of degrees of freedom that I have when I have legs. And very important, my goal is not to give feedback to the operator. Okay, same way when a cat purrs, it's usually not trying to give feedback to the owner. Okay, the Rover shouldn't be either. So everything about this legged robot is rhythmic. When it moves, the legs are touching the ground, they make sound. Errors that you have are also rhythmic. If the leg is slipping, it slips again, and it slips again, and it slips again. I built the option of the Rover having an inner melody that it follows. Maybe there's some aspect of a visual rhythm which gets us to the concept of dancing. So basically the questions that I'm trying to answer is, what does a dance notation for a hexapod look like? And what would I do with that dance notation? I would build some sort of module which translates the inner happenings of the Rover into a series of dance commands. And then when the Rover is walking or just standing there, it will dance according to what's happening inside. So right now, I only have a notation of movements, not a notation of dancing. And again, any suggestion would be appreciated. If you look on the internet, you can find dancing robots. They have dancing Roombas. They spin around and they spin around and they go in straight lines and they spin around at time to music. So the concept of dancing robots is not new. They also have dancing hexapods, but I haven't seen yet any notation which would be easy to connect to what's going on inside the rover. Okay, we talked about closing the loop, and the goal here is that if I close the loop properly, the activity should look more adaptive to the surface and activity. Okay, I should say command perhaps. In other words, it should look more natural. If you remember, the rover was walking on the road, it was just walking. It was told to walk and it was walking. It didn't appear to somehow interact with the surface, to somehow glide, or I'm not sure how to describe it. So be successful if when you look at the rover, you say, yes, this rover is aware of its surroundings and it's moving in a way which is responsive to its surroundings. Now, I'd like to show you tapping. Okay, we saw this before. Okay, so the rover's walking. It's tapping. Now it continues walking. This tapping is not part of getting from point A to point B. And tapping, of course, is very rhythmic. So I can have the tapping, I can have it picking up a leg, waving it and putting it down. And what I'm missing is some way of describing what is the right way of doing it. Not the right way, but a way of doing it, so this tapping won't be that I told it to tap, but maybe, you know, if it's walking, it taps according to a rhythm. Maybe it taps more when it's more overloaded or when it's not managing to move its legs properly. Maybe we can give it a song and it dances, you know, walks with that song. I don't know. So what does a rover want to do? I don't have an answer. I figured I would start with, it wants to create a more enjoyable rhythm. So I said it has a sense of rhythm. We can maybe define what a fun rhythm is for the rover. And then the rover does activities which generate a more fun rhythm according to its own judgment. Which means that when it reaches a pile of leaves, it will start jumping around. And when it reaches a flat surface, it will start tapping. I have a microphone waiting to be attached in order to listen to the sounds that it makes. I mean, the rover will listen to the sounds that it makes and react to them. Like I said before, I think that if I have a reference activity, it's easier to answer the question, what does a rover want to do? And the reference activity I'm suggesting is a feral garden rover. So if you have a feral animal in the garden, it's not getting its goals from a human being. It's reacting to the surroundings. Okay? And I want to focus on these activities that are not crucial for keeping it alive. In other words, not power, not how it gets power, not how it reproduces, or my rover doesn't know how to reproduce, not survival, and definitely not work. So if anybody has any ideas what you think a feral garden rover wants to do, please tell me.
I have two ideas.
Listening?
Number one is simply to move. This is the easiest probably to model because you've got automatic frustration built in that, like, if a rover gets stuck on a step or on a rock, that's frustrating because its only goal is to keep moving.
Okay.
Something more complicated to implement, or what I would, or even think about what it might mean, is seeking novelty. So a thing that a rover would like is to hear a sound it's never heard before, walk on a surface it's never walked on before, or go somewhere that it hasn't been before. So if it's just wandering around, seeking out novel things.
Okay, so let's simplify what you just said. If I have the rover walking around and let's say listening to the sounds that it makes, and the mechanism is not important, it keeps on looking for places where it will hear novel sounds. I just want to comment that while the rover has a camera, which has whatever you want analyzing the images, I realize that like a cockroach, and I've been reading about them recently, it doesn't really need to use its eyes in order to know interesting things about the surroundings, because each one of the legs actually acts as a sensor. You have slippage, you have getting stuck on things, and definitely if you have sounds. So I still need to solve this problem of how it identifies whatever it is as something interesting. But yeah, okay, that's.
I actually completely forgot about the camera.
No, but it's good.
But yeah,
Forgot about
yeah.
the camera, because I didn't talk about the camera, because the camera is just leading us towards a more sophisticated activity, and I'm looking for the low level, and what you described, yeah.
So yeah, I have a couple of comments. Like the part I picked up on was you made a strong distinction between utilitarian gaits that are related to something like, optimal energy use or something versus fun gaits, right? And I don't think there's actually philosophical distinction there. The two can actually be unified in a certain way. Like say you have a very tired rover and it wants to like maximize battery life and like get on with its like utilitarian survival tasks, then it might identify that this is the lowest energy gate with which to move, right? On the other hand, if its battery is fully charged, then it might not set a goal, but do something like, I want to actually operate at a certain energy level. And if the mission I've been given is only like 5 watts, but I actually am feeling energetic, so I want to operate at 15 watts, then you can ask, all right, how do I use up the extra 10 watts of kind of quote unquote fun energy that I want to use? And I think this actually maps well to actually a meta level utilitarian problem of like, when you have excess energy and you're in a feeling bold and in a mood to take risks, then you are actually doing a utilitarian thing, which is exploring your environment in ways that are not related to like immediate goals, right? And there's 2 ways animals seem to do that. One is what you were calling an internal music. And I think one of the biggest sources of internal music is, bodies have like symmetries, they have masses, they have natural frequencies, harmonics. So if you look at, for example, like I've seen a bored elephant and at a zoo or somewhere, and it actually sways in a particular rhythm that very clearly is almost like the pendulum frequency of the elephant's body, right? So I would say there's an internal source of signals you can use, which is natural harmonics and symmetries, and an external one, which is you watch signals in the environment, and if you have surplus energy, you kind of like just track them, and then you kind of want to get an improv with that. And the example I'm thinking of is snake charmers are kind of interesting because snakes are actually deaf. And when a snake charmer is using their instrument to like make the snake dance, the snake is not actually listening to the sound of the playing, but the swaying of the snake charmer's head. So it's literally just doing like something like a phase locked loop. It's looking at a sinusoid in the environment and just tracking it, right?
Yeah.
So that's like a responsive use of energy, or sorry, how do I put it? Reactive use of surplus energy from reacting to the environment versus generative use of surplus energy, as in like draw on some inner symmetries and things like that. So I think your yeah.
That last distinction wasn't clear.
Okay. So you have a surplus of energy to use, and the question is, what kinds of movements are you going to make, and where are you going to get ideas for those movements, right? So the ideas for the movements can either come from sort of your inner natural rhythms, which, like a pendulum has a natural frequency, that kind of thing, but more complex in the case of the human or rover body. And the other class is you respond to signals in the environment by, in the simplest case, simply mimicking them. And there's a third source, which is actually just randomness. And this relates to risk in an interesting way, which is if your spider in the last 10 things it has tried, it has mostly succeeded by maintaining some sort of Markovian state of like success, it might decide it's in a very high risk taking kind of mood, and it might try risky random things. So in the stuck position you showed us, you gave it a command that is something like, I insist you do something, right?
Right.
And insisting can be interpreted with various levels of risk. It could very tentatively try to lift that leg, or it could very aggressively like max out its motor power. So basically when you force it to like push harder on a trade-off, in this case, actually what you're doing is a trade-off between the first and second law of robotics in Asimov's sense. We talked about that a couple of weeks back. So first law is you must obey the commands of the human. Second law is you must preserve yourself. And by forcing your command of like, I insist, you're creating like higher weight bias on the human command. And then the robot can decide based on its energy level and general fitness level, how much risk it wants to take. And it might like apply an equal weight to the second law internally and say, all right, based on how strongly you're insisting versus how much energy I have versus, how many of my motors are broken out, I'm going to very aggressively pull this motor by like, over stressing the motor voltage, or I'm going to be very tentative because I'm not feeling very secure. Or this is where randomness comes in, because risk is related to how random you're willing to be. Like, you might just shake the whole body, like just send random white noise signals to all the servos and create like almost a spastic shaking around, which humans often do. Like one of the things we do when we get stuck and don't know what to do is do something random, like, kick the side of the car and hope it starts, that kind of thing, or to your own body. So I would say your bounding box of like where you can generate basically what you're calling your playful dance problem is external environment, internal environment, and randomness. So internal environment is internal symmetries, external environment is signals you might respond to, and randomness is just generate pseudo-random stuff and inject it into actuators. And those, I think, are your three sort of input signal sources, and the two sort of things that shape your output behaviors is one is the risk level you're willing to take, and the other is the energy level. And I think generally biological systems seem to be primed around the more successful I have been recently and the higher my energy level, the more risk I'm going to take. And then you synthesize a behavior signal based on that boundary condition in a way. So I don't know, that's the general conceptual approach that occurs to me for this. Does that make sense?
Well, basically, it seems to be going in the direction of emotions. If we take the last thing you said, so I'm basically defining happiness as how successful have I been recently. And if I'm happy, I move into more risk-taking mode.
Yep.
So I have to define a small set of Rover emotions. And I think the emotion is not how much energy do I have, but do I think I have enough energy for what I need?
Yep.
Do I feel like I have excess energy? I'm about to get recharged or something like that.
Yeah. Right now, I'm anchoring very strongly on the kittens I have running around in my room. Plus, we have a really old 18-year-old cat. And it's kind of interesting. Like the old cat is also sometimes in a playful mood, but he's so old and arthritic. If you wave a ribbon at him, he might like very weakly swat at it, but he's not really playful. Whereas the kittens, they're like simply bursting with energy and they have not yet encountered any unsafe environments. So even the slightest stimulus, it'll sort of send them into a frenzy. Like you leave them in an open room and like throw like a small ball at them, they'll like drive themselves nuts for 15 minutes. So I think energy is an input just based on my observation of the old cat and the young kittens. But yeah, I think emotion is the right sort of higher level thing to go after here. So whether it's some function of recent experiences, or it could be personality traits as well. Like if you think about all these behaviors, one way to think about why there's a particular style to a rover or a robot or an animal, it's like these rovers and animals are constantly solving NP-complete problems for which there's no like closed form, formal good solution. So they're going to like converge on heuristics that seem to work well in the domain, right?
Mhm.
And the heuristics you converge on, I think that's what we end up interpreting as a personal style. Like even though these kittens are very young, the 4 we have right now, they're like about 7, 8 weeks old. Already very clear personalities have emerged, and you can see them sort of developing their conditioning based on like both. I guess there's some genetic differences in there, like hard-coded heuristics of whether they're like more or less playful, more or less exploratory, but they also learn from each other really fast. Like if one of them figures out how to jump over something, the other 3 will pick up very quickly. And, so there's like multiple things going on there. So I would say the style is a mix of like hard-coded versus learned problem-solving preference styles that sort of manifests as a kind of aesthetic of use of surplus energy, right? Like 2 kittens that have like 2x extra energy than they actually need, they're not going to use this energy in the same way. Like I've seen one of them kind of like do pretend stalking and like, oh, did you just see one jump up behind me? So, one of them might go exploring at the edges of the room that we've allowed them to be in. Another one might simply, run around in circles or keep trying to jump up on a high level that it has not yet attempted before. So they do very different things already, even though they have had like basically the same environment for the last 5-6 weeks.
So what you're saying is, to translate into rover language, if I have a rover that has a action sequence called the stalking or called running around in circles, if it has a lot of energy, it might randomly decide to run around in circles for 2 minutes.
Yes, which is what animals seem to do as well.
Okay.
Oh, I posted a couple of links in the Discord. One is an article by me on gaits, which I was writing about for a different reason. But the other one is by David Graeber, who wrote this really nice essay on play, which is kind of interesting because normally he's dead now, but he was a super socialist, political polemic guy. But this is an interesting thing he wrote about why animals play. And he starts off by discussing a worm that was just dangling from some grass and was just doing playful movements in every possible way it could twist. So that might provide some inspiration. It was a very surprising thing because I don't actually like David Graeber. I was very surprised to read this one thing he wrote that goes off on a tangent on why animals play, basically.
Well, I can tell you why the rover needs to play. If you remember, I started at the beginning and I talked about evasive movements. If a leg gets caught, it needs to move out. The question is, how does a rover know what movement will release its leg? And part of the answer is it learns these movements, potential movements, while playing.
I think there is this concept called novelty search. I think Kenneth Stanley or Kenneth Stanley, I think is in OpenAI now. So one of his particular ideas is that AI can come only, like better AI can be built by pursuing novelty rather than planning for some specific outcomes or something. So the idea is like, if there are some steps to a problem where you cannot find the bridging steps, and those bridging steps can be found purely by pursuing novelty, and there's no guarantee on finding it by optimizing for a objective and finding the minima or the maxima or something like that. I think he has a talk called How Greatness Cannot Be Planned or something.
There's a book as well. The title sounds familiar. That's probably it.
But here, in order to do what you just said, the Volvo needs to identify that it got a result based on this playful movement. It needs to identify that it actually found a bridging step. I just don't know how to do that. In other words, let me think about it. A Volvo walking around and it learns how to climb. It's just playing around and it manages to climb up a step. Okay, so that's very valuable, and I'd never get there by optimizing. But now it's not Maier who needs to identify that it learned something interesting, but the Rover. And I don't know how to do that yet. Okay, so I'm not saying it's a bad idea. I'm just saying, unlike all the other things still here that I can, think of how to do them, that I just don't know how to do.
I have a suggestion on how to do that, which is just try to compress the behavior or the energy profile. Like I think evolutionarily, these things evolve when you do a bunch of random things and one of them turns out to be unexpectedly elegant. And I think the way you translate unexpected elegance into sort of generated behavior is some sort of test of compressibility. Have you guys read the Schmid-Huber paper, Driven by Compression Progress? It's one of my favorite papers.
Sorry, everyone,
very-
I have to jump.
Oh, okay. So it's a good paper on precisely this problem, which is, let me just find it and post it first.
I don't expect movements in the garden to have that type of elegance.
I need to jump too. Okay, see you next week.
Yeah, we should probably wrap in a couple of minutes anyway.
Okay.
All right. Yeah, I think you'd be surprised. Like, for example, you were talking about like the terrain in your garden. For example, if there are tiles, so your garden may not have this particular regularity, but say there's a terrain with tiles, and your rover discovers that matching its step length to the tiling frequency creates a particularly both pleasant walk in terms of like, maybe the smoothness of the energy use profile, plus also it's like creates like a nice harmonic sound or something. Like you can invent some sort of elegance measures. And I think there's a generalization here somewhere, though in this particular case, it may be specific. But yeah, and in terms of evolution, if you look at the gaits of horses and things like that, it's pretty much always they turn out to be energy minima in the ways the particular body can move. Like if you look at all sorts of random ways the limbs could move, it turns out that the animals have evolved gaits that tend to be energy efficient for that particular, rate of movement or something. Anyway, yeah, so we should probably wrap in a couple of minutes.
I'm done.
All right.
I had one more thought around the other movements that could be fun to incorporate, and how it kind of applies to rhythm. I don't know how many people have this experience, but having a few infants where you have to stay up super late at night, parents I know tend to get into a mode where you're like, sort of like getting off a boat and you have your sea legs where you're just kind of constantly moving because you're normally carrying a baby and trying to calm them. And so having this like constant kind of sway, or even like, sometimes it's like based on a rhythm or a song kind of in your head, and you're kind of like, just even without thinking about it, you're always just kind of moving just a little bit. Even if you don't have a baby anymore, a little bit on you. You just can't stop it.
My grandkids come to visit, so
Yeah.
All right. So looking at the calendar, looks like I'm actually up next. So I have to think about, can I make some progress in the next week enough to talk? So I'll do my best to do that. And if not, I'll sort of go to plan B and pick a special topic to discuss. But hopefully I'll have at least a small step of progress to show. All right. So I'll see you guys next week.
bye.